All right, good afternoon, everybody, and happy Friday. So while I'm finishing taking attendance, I'm going to go through a couple of announcements. So first off, we have a quiz next Thursday. It'll be all over electricity. So it will include what we're going to be going over today in class. All right. Yesterday, we got our lab, our parallel and series circuit lab. That is due on Tuesday by 11:59 p.m. A reminder that when I say it is due on Tuesday, it does not mean do it on Tuesday. The reasoning for the due date, is so that you guys have enough time to ask me questions if you're having trouble with the simulator. So let's say you are having some troubles, or you don't remember what I went over in class yesterday. That little bit where I introduced the simulator and how to use it, it is recorded, and if you hit Zoom recordings, you can go and see it on there. If you do have any questions that's not really covered in that Zoom recording, you can inbox me and we can work that out and we can find a time to meet. And lastly, I know that the schedule is still changing. So as soon as I know what the schedule is for next week, I will update my Canvas homepage and I will let you guys know. So if you're not sure on Tuesday when we come back, because we will not be meeting on Monday because of MLK Day, if you're not sure of what the schedule is, you can go to my homepage and you can see it there. All right. And last reminder is that cameras are highly encouraged to be on during class time.
My Zoom literally doesn't have the camera icon. Like I can't even turn mine on.
Okay. We can talk about that a little bit later, okay?
Okay.
All right. Okay, so while I'm finishing attendance, does anybody have any questions that they want to ask me? Okay. With that, we'll move on to today's notes. Okay. So the first thing we're going to do is we're going to review. So here I have a circuit drawn. This is my battery. And then I have light bulb number 1. It's connected to my battery with these black wires. So it's fully connected to the battery by itself. I then have light bulb number 2, which is connected with the red set of wires to the battery completely by itself. Is this diagram showing a parallel or a series circuit?
Parallel?
Yeah. Why do you think it's parallel?
Well, most of the diagrams that I've seen that were parallel have that on the left side, those lines right there. So that's how I remember it.
Okay. So the lines on the side represent our battery.
Oh.
So to make it a parallel circuit, our parallel circuits are connected separately to the battery. So my first wire, my first light bulb, it's completely connected to the battery by itself. My second light bulb's completely connected to the battery by itself. So my light bulbs are not connected. Yeah, so my light bulbs aren't connected to each other. So that makes it a parallel circuit, because if I were to cut this black wire, light bulb number 1 would turn off. But light bulb number 2 would stay on because it's connected to the battery on its own. Are there any questions about that? Okay. So for this parallel circuit, my battery, so right here, has a voltage of 40. Based off of what we just discussed. So my light bulb number 1 is connected to both ends of the battery. What would the voltage of light bulb number 1 be? Would it be equal to the voltage of my battery? Or would it not?
It would be halved because the battery's outputting at 2 different bulbs, right?
So not quite. In my parallel circuit, it is connected to both ends of my battery. So it is connected to both ends of my battery. So it's going to be getting the full voltage of the battery. If this was a series circuit where it's only connected to one end of my battery, that is where we half it. So in this case, for my parallel circuit, light bulb number 1 is going to have the same voltage as my battery. It's going to have a 40 volts going through it. Are there any questions about that?
No.
Okay. So let's look at another example. So on my right, I have another diagram of a circuit. So here, I have my battery. This black wire connects my battery to light bulb number 1. This red wire connects my battery to light bulb number 2. I then have a purple wire that connects light bulbs 1 and 2. Is this diagram an example of a series or parallel circuit? Yeah, so this is an example of a series circuit. So it is a series circuit because everything is connected. So let's say if I were to cut that red wire, both of my light bulbs would go out. Unlike the example on the left, my parallel circuit, if I were to cut like the red wire, only light bulb number 2 would turn off. Are there any questions about that and why this is a series circuit? So this battery for my series circuit has a voltage of 80, so it has 80 volts. What would the voltage for light bulb number 2 be if it's only connected to my battery in one spot? Yeah, I would have light bulb number 2's voltage would be 40 because it's only connected to my battery in one spot. So it's only going to get half the voltage from the battery. So it's going to be 40 for my voltage.
Okay, so with number 1,
Mm-hmm.
that voltage was
40.
40.
Mm-hmm. My battery's voltage was 40. So that was my total voltage.
Okay. And that's the voltage for for light 1 and 2?
Yes.
Okay.
So in my series circuit, both of these are only getting half of the total voltage. Let's say I had a series circuit with 3 light bulbs, and my total voltage still stayed 80. To find the light bulb 2 voltage, in the case of 3 light bulbs, I would take 80 and divide it by 3. Okay. So in our lab, be sure to read the questions because it may ask you for either a series or a parallel circuit to measure the voltage of your light bulbs or to estimate what they would be. And you would have to take into consideration if it's a series or a parallel circuit. So my parallel circuit, the light bulb gets the full total battery voltage. In my series circuit, it gets whatever number the light bulbs are, and you divide the total voltage by that. So in this case, it's 2. So I'll take 80 divided by 2, and I get a voltage of 40. All right. So before we move on to today's material, does anybody have any questions about this? About our parallel and series circuits? Okay. So today, we're going to be learning about electrical power and energy. So electrical power is the rate at which electrical energy is converted to another form of energy. So an example of that is when I plug in my microwave. Once I have that in the outlet, my microwave is going to take that electrical energy from the outlet and convert it, when I'm using it, to thermal energy to heat up my food. What other everyday objects can you guys give as an example to me that takes energy and converts it? Yeah, an oven is one that would work exactly the same way as the microwave and a refrigerator. So that would take the electrical energy and then it transforms it into another form of thermal energy, so it's cooling. And same with a toaster, that's exactly the same as the oven and the microwave. Any other examples? Yeah, wind turbines are a great example. But what is happening with wind turbines is that it's taking energy from the wind and then converting it to electrical energy. And then we use that electrical energy for our multitude of objects. But yeah, that's a great example. It's just a little backwards, but that's okay. It is creating electrical power. Yeah, a heater is the same thing, and so is a fan. So what those are doing is taking electrical energy and either creating heat, or for a fan, it's creating mechanical energy with blades. All right, good examples. So now we're going to talk about calculating electrical power. So we're going to learn a new math equation today. So devices, electrical power depends on the voltage difference across that device and the current through the device. So two of these terms should sound very familiar. So voltage difference and current. To define our equation, we have this below. So we have electrical power, which has our units of watts, or our capital W, is equal to current with our unit of amps, so our capital A, multiplied by our voltage difference, which is our capital V. The symbols we use are P equals I times V. And the triangle we use has our P, our power at the top, and our I and V at the bottom, so our current and our voltage difference. All right. Is anybody still copying this down? Okay. So what we're going to do for the rest of the class is we're going to go through some examples on the marker board. These examples will not be posted along with the notes. So if you want to write these down as I'm going through them, that is a great thing to do. So then you have these examples handy. So if you haven't already done so, grab some pen and grab some paper or grab a pencil, whatever you want to use to write with. So on the board, we have our first example. And let me know if you guys can't see something. So the current in a clothes dryer is 15 amps when it is plugged into a 240 volt outlet. What is the power of the clothes dryer? So to start off with a problem like this, I'm going to reread my problem and box in my values given and underline what I'm trying to find. So rereading it, the current in a clothes dryer is 15 amps. I'm going to put a box around that. When it is plugged into a 240 volt outlet, put a box around that. What is the power of the clothes dryer? I'm going to underline power. To find electrical power, or to do my electrical power problems, I have my three symbols. I have P, I, and V. So from what I boxed in and what I underlined above, do I know P?
No.
I don't. So that's going to be my question mark for this question. What is I, my current?
15.
My current is going to be 15 amps. And then V, my voltage.
240.
I have 240. Before I solve this problem, I'm going to write out my triangle. So for my triangle, out of P, I, and V, what am I going to put at the bottom?
I and V.
I'll put I and V. So that will leave P for the top. Once I have my triangle, and once I know what I'm trying to solve for, I will then cover that up. Once I cover that up, I see that I need I, and since they're next to each other, I'm going to multiply by my V to help solve this. So to rewrite what I found out from my triangle, P is equal to I times V. Once I have this equation, I can take what I got from my word problem above and plug in my values. So P is equal to 15 amps times 240 volts. When you plug 15 times 240 into your calculator, what do you get?
3,600.
You'll get 3,600. And for power, what are my units for power? Yeah, my units for power are watts. So it's capital W. And that is the answer to this question. Is there any step that someone wants me to go through again, or anywhere that someone has a question about this example problem? Okay, I'm going to erase it, and then we're going to move on to the next one.
When I go to the restroom.
Reminder to stay on mute. Okay, so we have a video disc player. When it's not in use, so when it's not playing videos, it still uses 6 watts of power. When it is plugged into an 120 volt outlet, what is the current of the disc player? Let me know if you guys can't see something. Okay. Do I know what my P is for this problem? And if so, what is it?
6.0.
6.0 what?
Watts.
Watts. Reminder to always put in units. All right, what about I? Do I know what my I is for this question?
No.
No. So I is going to be question mark here. What about V?
120.
It's going to be 120. Okay. So from the word problem above, this is what I got. I'm going to go over and look at my triangle. See that I is what I'm trying to find. So I'm going to cover up I. What do I need to do to solve for I based on my triangle?
Divide
Divide what by what?
P by V.
So P over V. Once I have this equation, I can plug in my values. So for P, I have 6.0. For V, I have 120. When you plug in that into your calculator, what do you get?
0.05.
I get 0.05. And what are my units for current? For I?
Amps.
Yeah, it's amps. So it's capital A. Okay, does anybody have any questions about this problem or any step that I went by too quickly? Okay, so I'm going to erase the board and we're going to go on to our last example. Okay, so I have a flashlight bulb uses 2.4 watts of power when the current is 0.8 amps. What is the voltage difference of the batteries? So what's my I from this word problem? If I know it.
0.8.
So my current is 0.8. What about V? Do I know what V is?
No.
No. It's asking me to solve for voltage difference. So that's going to be my question mark. And then P. What would my P be then?
2.4 watts.
2.4 watts. All right. So based on the word problem above, we were able to get this out. I know that I'm trying to solve for V, so my voltage difference. Using my triangle, I'm going to cover up V. By covering up V in my triangle, how am I going to set up this equation? What is V equal to?
P over I.
Yeah, it's equal to P, so my power divided by current. Once I have this equation, I can plug in the values I found from above. So for this, my V is going to be equal to 2.4 watts divided by 0.8 amps. When you plug that into your calculator, what do you get?
3.
3 what? If it's V, what's my units? So for voltage difference, what are my units? Yeah, so my units are volts. So it's capital V. Okay. Is there a step that I went by too quickly for, or are there any questions about this example problem? Okay. If there are no questions about this example problem, that's the end of our notes for today. Some reminders before I let everybody go is that on Thursday, we have our first quiz. And that on Tuesday by 11:59 p.m., your lab is due on Canvas. I'll update the schedule as soon as I know what's going on. So if you're confused on Tuesday about what the schedule is, I will update it for you guys. So you can go to my homepage and you can scroll underneath the Zoom's recording buttons, and that's where the schedule will be. All right. You guys can stick around if you have any questions, but otherwise, you guys are free to go. Have a great day. Have a great long weekend. I'll see you guys on Tuesday.
Thank you.
Bye, everybody.